So look at your little half sheet of paper with the directions. We're going to graph equation A on this first grid. Take your first color. Mine is going to be purple. It does not matter what yours is, though. It doesn't have to match mine. Just pick a color. Okay? So let's review our transformations. Look at equation A. How did this get transformed? We're getting back there. Down 3, good. Well, I'm not looking for the stretch or shrink, just the shifts. Down 3, right 1. We got there. Okay, so what you're going to do is go down 3, right 1, and put a point. Now be really careful, because if you're using a marker or something, you're not going to be able to erase it. All right, now I want to plug in some other numbers. I'm going to make a little table right here. If we plug in something that does not work, what will we do? Try again. Okay, what do you want to try? 3. Let's try 3. Let me write it on the... I like to write what I'm plugging in immediately, because after you like plug it in, sometimes you forget what you plugged in the first place. Like this whole graph is going to be purple for me. So whatever color you picked, the whole graph is going to be that color. It doesn't matter what color this is in. This is just our thoughts. This is just our work. Okay. Here we go. 3 minus 1. Very good. 2. I'm waking you up in the morning. 2 times 4. Good. This is going to work out. Cube root of 8 is 2. 2 minus 3 is -1. So you can plot 3, -1. And again, work smarter, not harder. Watch me point to this. I know this is the center. That's the very first point we did. And I know it's cube root, so it's going to be like a wiggly thing with this point as the center. So I can just take that point and reflect it down here. Now, when you connect this, and again, you're using your first color, mine's purple, you need to make it go all the way to the edges of the grid, okay? So it's going to do something like this, and just make it go all the way to the edge. And that is it for the first one. And what we're going to do is pick a second color, so trade with somebody near you or something. And we're going to do the exact same thing with graph B, just in a different color. Oh, wait, I'm sorry. One other thing. We have to label. You want to label this as A in the bottom left corner, the bottom right corner, and by the axis. Put an A in all 3 of those spots. You'll see why at the end, but just make sure you label that so you know which graph it is. Sorry, I almost forgot one of the most important steps. So now we're going to graph B. So pick a different color. Mine's going to be green. It doesn't matter. Yours doesn't have to match mine. Just pick something different. Okay. What kind of graph is B? It's a swoop, like this. All right. It moved what direction? Up or down is what I'm looking for. Up 1. So you're going to go up 1 and dot that in. That's where the asymptote is. Usually it's right on the axis, but we went up 1. So you're going to go up 1 and dot that in. Now it did go right 2. Do you guys see that as well? The x minus 2 in there. So when we go to plug in some numbers, if it went right 2, 2 is probably a good number to try to plug in. You can plug in whatever you want, but if it went right 2, you know, start with 2, right? Let's see what happens. 2 minus 2. Good. Anything to the 0 power, 1 plus 1 is 2. So we get 2, 2. All right, you want to do 3? 3 minus 2 is 1. 2 to the 1 power is 2 plus 1, 3. 3, 3. You know, no one else said anything, so I don't have a problem. That bothers you guys way more than me. If you're talking to me, I'm like so happy. All right, and then what else do you want to try? 4. Let's do 4. 4 minus 2 is 2. 2 squared 4 plus 1, 5. So 4, 5. And again, what you want to do when you like connect it, I almost said color it in, sort of what we're doing. Make it go all the way to the edges of the grid. So make it go all the way to the edges. And then label this one at the bottom as graph B, on the left, on the right, and in the middle by the axis. C is going to be a less difficult one. Just looking ahead, I'll still pause, give you a chance to finish. But why is C an easier graph? It's linear. Good old y equals mx plus b. Pick a different color. Mine's going to be pink. All right. How can we start to graph this one? Start by going down 3. And then, I'm sorry the colors don't show up very well on here, but that is pink. All right. And then what's our slope? 2. And it's really 2 over 1. So you're going to go up to right 1 from that point. So go up to right 1. And again, you want to go all the way to the edge. So since this one's linear, that's not that hard. Just maybe keep on putting points in there to make it like real accurate. And then label this one as C in the left, the right, and the middle. I apologize for D. I had a typo. What kind of function does it say that is? I wanted it to be absolute value. Are you like breathing a sigh of relief as well? Like, okay, good. Like, that's better. I wanted it to be absolute value. I'm really sorry. All right, my last color is going to be blue. Pick a new color. And how did that one shift? I'm looking for words like up, down, left, right. Up 7, left 1. All right, so from the center, we're going to go up 7, left 1. Put a point. Now, with absolute value, you can make a table of values if you want to. That will always work. But what shape is it going to be? Yeah, like if you know it's going to be a V, that helps you out. Each side is linear. So you can use this -2 as your slope. A slope is only appropriate to talk about with things that are straight, right? If it's curved, you can't talk about a slope until calculus next year, and then we will. Okay, but for right now, only if it's linear. But both sides are linear, so you can use the -2 as your slope. So from that point, go down to, now it's like to the right and the left because it's symmetric. But use that -2 as your slope and just keep on filling in points. And again, you want to go all the way to the edges. And then label that one as D on the left, right, in the middle. And then I'm going to pause there until everybody's done. And I want you to wait until I give you the next set of instructions to do anything. Because if you don't follow instructions on the next part, it's not going to work. And I want it to work for everybody because this turns out really cool if you follow the directions. Here's what we're going to do. And I'll pass out scissors, or if you have your own scissors, you can get those out. But listen until I give all the directions. You're going to cut these 4 grids out. And then what I want you to do is place them A on top, B underneath that, C underneath that, D underneath that, so that you have a stack. Does that make sense? And make sure they're all facing right side up, because I always get somebody that puts one upside down and it's not going to work. All right. Cut them out. Where do the scraps go? In the trash, thank you. You're gonna cut them all out, stack them. I will come around with the stapler and staple them for you, okay? So once you have them cut out and we have, A, B, C, D, we wanna turn it into a flip book. Watch all of what I do before you then do it, okay? Watch, then you can repeat. We are going to cut vertically at x equals -1 and x equals 3. Watch. Do you see how right here is -1? Right, like this is 0. Do you see right here is -1? Watch me do it first. Ready? Okay, I'm gonna cut vertically at -1. Wait for it. I'm gonna stop right about there. If you cut the whole way through, instead of one flip book, you will end up with 3 individual pieces of garbage. Do you understand? So you want to do that in -1, and then what was the other one? 3. So do you see how right here is 3? 1, 2, 3. So I'm going to cut vertically at 3. But when you get about to where the f of x there is at the top, that is there at the top, I know how to speak. Stop, so that you end up with one flip book that is still connected and not 3 individual pieces of garbage. Okay, so here's the whole point of what we just did. We're gonna have a conversation about continuous versus discontinuous, and use your common sense and your instincts, because whatever you think that means, you're probably right, okay? So here, first of all, let's talk about the domains, because what we did is we chopped the domain into 3 pieces. What's the domain, and remember you read left to right, of this first section? If you go left to right, what's the domain of this first section? -infinity up until, where did we cut? -1, good. So it's -infinity to -1. Now here's the dilemma with the bracket versus parenthesis. The second piece is gonna pick up at -1, right? Like they each pick up where the other leaves off. You need to put a parenthesis on one and a bracket on the other. And it actually doesn't make a difference. You just need to include the -1 somewhere. Does that make sense? So I'm gonna put the parenthesis here and the bracket here. If you wanted to do it the other way around, that's totally fine. You just have to include the -1 somewhere. If you put a bracket on both, it does not pass the vertical line test and it is no longer a function. So you cannot include it on both parts. So one or the other, but not both. Now, what's the domain for the middle section? We said it starts at -1. Where does it end? 3. Now, again, it doesn't matter where you put the bracket and where you put the parenthesis. The third piece is going to pick up at 3. You just have to include it on one of them. So one or the other, but not both. It really doesn't make a difference. And so the last piece is 3. Perfect, to positive infinity. Focus over there, guys. Okay, so now we're gonna go through and do these steps here. Flip the piece, and here's my analogy for this, because I don't know if you had one of these books when you were a kid, like you had a childhood, right? Okay, I had one of these books when I was a kid. Mine was dinosaurs. I've seen them made out of like cats, dogs, clowns, everything. Mine was dinosaurs. But it had like the head of a dinosaur, the body of a dinosaur, and the tail of a dinosaur, and then you could flip them and mix and match all the different dinosaurs. We just did that, but with math graphs, okay? So what you wanna do, hey guys, flip it so that we are continuous at -1, and that means the 2 pieces are gonna meet up, and at 3. We wanna be continuous the whole way through. Now I always get some smart person that's like, well, just leave them all on A. Okay, I get it, right? But you wanna try and flip it so that the pieces meet up at both of them. See if you can find a way to do it. I actually don't have memorized what it is, but I know that.
I forgot that you can use
Is CAD gonna work? Well, but we don't want AA. There we go. Do you see that? CAD. Do you see how they all link up? I think there might be one other. So you said A, C, and B. All right, hold on. Let me get there. I'm recording this, so I want everybody that's absent. Oh, look, that one's good. Yeah, no, it's good. Yeah, yes, you are correct. ACB. All right. Hey guys, now let's do one that's continuous at -1, but discontinuous at 3. So we want to be continuous at -1, but discontinuous at 3. So like CAC is what I found. Or C, no, we're just verbally talking about it. You don't have to write it down. CAB. Did anyone find another one? What was the other one that linked up? It was A, was it A and then something? AC, Franken functions. ACD, you see that? All right, now make one that is discontinuous at -1, but continuous at 3. So discontinuous at -1, but continuous at 3. Bless you. Yeah, so discontinuous at -1, but continuous at 3. What would you say, A, B, C? Okay, you guys seen how there's lots of options here? Oh, I like that one. All right, now make one that's discontinuous at both -1 and +3. That would be pretty much like anything else, right? Would you say C, D, A? Wait, D and A match up. Oh, okay. Oh, there we go. All right, have you got it? Here's the takeaway. A piecewise function is a function that has been cut into pieces. You have cut the domain in certain places, and then you can have a conversation about the continuity. Does it match up or does it not? Do you see visually what's going on here? Okay. All right, so now what we're going to do is graph these, but I took away like the flip book part of it. You're gonna have to graph it without them. So there's a couple different ways you can do this. You can graph like the entire function and then just erase the part that you don't want. Or you could just plug in numbers up to like where that cut would happen. Kind of up to you. I sort of see like what I'm dealing with and then decide how I'm gonna approach the problem. But where is the cut happening for this one? Like if we were to actually make a flip book and then cut it, where would we cut? At x equals what? 1. So you have to imagine like a cut happening right. Don't actually cut your paper. We're not going to do that now. But you have to imagine like a cut happening right at 1. Okay. So let's graph the first function. What kind of function is that? Like what is the parent function, I guess? It is exponential. It's a swoop. It moved up or down? Down 4. Go down 4 and dot that in. Now, I'm only going to dot it on the left side. Why would I only dot it on, you can dot it the whole way through, I suppose, if you want, but why would I maybe only dot it on the left side? We're only going up to 1. We only want to graph this for a domain x less than, oh, and let's have that conversation just real quick. Let me write that off to the side. When you see a symbol like one of those, you would put an open circle. You're going to be okay. All right. And when you see a symbol like this, you're going to put what? All right. Whenever you have a symbol like this, you're going to have what? Closed circle, because you're actually including the point. You okay there? Okay. All right. Let's go ahead and plot some points for this exponential equation. And you only want to plot numbers smaller than 1. So like, what do you want to try? Let's do 0 if that's okay with everybody. And we might not really be able to get 3 whole points on this. But let's start with 0. 2 to the 0 power. 1, good. Minus 4. 1 minus 4. There we go. So 0, -3. Now, I don't really want to do -1. Let's look at what would happen if you try that. 2 to the -1. What it does is it flips it and you get 1/2. I don't want to deal with plotting that though. Can you guys please stop it? So I'm actually going to plug in 1, and here's usually what happens. Miss Cole, we can't plug in 1. There's not an equal to. You can plug in 1. It's just you're going to put an open circle. In fact, you want to plug in that value where the cut happens. You need to go all the way up until that value. So let's plug in 1. 2 to the 1. 2 minus 4 is -2. So 1 -2, but make sure you put an open circle. And so what you're going to do is connect that, but only for values smaller than 1. So if you drew in the whole thing, and just watch me point to this, it would be this whole swoop. We just cut it off right there, exactly like we cut with the flip book. Are you following me on that thought journey? We only went up to 1. Now it's going to be something different, like if you had flipped the flip book, for bigger than 1. Now I kind of cut you a break there. What kind of function is this? Like it's just 3. Thank you. Constant at 3. So it'll be a flat line, a horizontal line at 3, but just don't draw it the whole way across. You want it to pick up at 1, and what kind of circle? Closed. So it's going to be a flat line at 3, horizontal line at 3, but just make sure you pick it up at 1. And you can see like where that cut happens, like where that jump is occurring. And so is this function continuous or discontinuous? Discontinuous, and we'll abbreviate. And you should always say where, like at what location. So discontinuous at x equals 1. Good. Now you also need to be able to evaluate these functions. So I'm just going to throw a few numbers out here and we'll just try and evaluate, okay? Say I asked you for f of 0. You would just look at the graph. Here's 0. Where's that point? -3. Good. Say I asked for f of 2. I'm just making some up as an example. Here's 2. That value's at 3. Do you see what's going on there? Like you just find where that point is. It's an input output kind of thing. What would f of 7 be? 3. How about f of 42 million? 3. Okay. Let's try another one. Where is the cut happening on this guy? 3. So like your cut is going to happen right here. What kind of function is this? Quadratic. It went up 8. And it's also going to be reflected. It's upside down. Okay. So go up 8. I actually think that's the top of the grid. And it's going to go upside down. Let's just plug in a few more values. What do you want to try? We're centered at 0. So what would be like a clever choice to pick? 1. Let's plug in 1. You ready? 1 squared. 1, 8 minus 1, 7. So you get 1, 7, and then you also get the symmetric point because it's going to be a parabola. Let's try 2. 2 squared. 4. 8 minus 4 is 4. So you get 2, 4, and then the symmetric point. Now, I actually want to go a little bit further because the cut is happening at 3. So you always want to plug in the value where that cut is happening in the domain. So 3 squared, 9, 8 minus 9 is -1. And what kind of circle? Closed. Good, because it has the equal to. So 3, -1. And you only want to connect it for values to the left of 3, values smaller than, it's like you amputated the graph is essentially what happened. The domain is getting cut off there at 3. And again, some people like to draw the whole graph and then just erase the part they don't want. That's totally valid as well. Oh, I forgot to write in a -1. All right, and then this one, what kind of graph is that? I almost said the answer. It's linear, but we only want to graph it from 3 onwards. Can we plug in 3? Yes, but what will we put? Good. All right, let's plug in 3 because you want to start at 3 and then go onwards. 3 minus 4. Oh my gosh. 3 negative 1 is right there. You cannot put an open circle on top of a closed circle. What's happening is the two pieces, like they meet up, right? They're going to link up. So we're going to start there. Like it already is a closed circle. So since we got 3 negative 1, it's just that they're going to meet up. And then what's the slope of this line? 1. So from that point, you're going to go up 1 over 1, and it's going to look like this. So is this continuous or discontinuous? It's continuous. And if it's continuous, you don't need to put at x equals whatever. It's continuous like everywhere. Let me just throw out a couple more values. Like here, let's try and evaluate these. Okay, because you're going to have to be able to do that. Let's do f of -2. Bless you. So you would find -2. Look, you can just point to it. There's no work. -2, and where is that output value? 4. Do you guys get what I'm saying? Like, do you feel like you could evaluate these? Bless you. All right, one more. Bless you. Are you okay? Okay. Allergic to piecewise graphs. All right, where is the cut happening on this one? 3. So you have to imagine a cut happening right here. It's 3. So let's go ahead and graph the first one. It's cube root. So it would look like a sideways wiggly thing. How did it get shifted? Like, let's find the center. I'm looking for words like up, down, left, right. Left 5, and bless you, down 1. Go left 5, down 1. And then we're going to pick some points around -5. Like if we're centered at -5, you would want to try numbers near -5. So like, let's try -4. Does that make sense? Like if you're centered at -5, pick numbers close to -5. Here we go. -4 plus 5. 1. Very good. Cube root of 1, 1. Minus 1, 0. So -4, 0. And again, work smarter, not harder. If this is the center, and I know it's going to be this sideways wiggly thing, I'm going to put another point here, and it's going to wiggle through that. And here's the only thing. You do also want to plug in the cut point, which is 3. But Ms. Cole, we can't plug in 3. Oh, yes, you can. It's just you're going to put open circle. You still can plug in 3. It's just going to be an open circle. That's all. Ready? 3 plus 5. 8. Cube root of 8. 2 minus 1. 1. So 3, 1, but an open circle. You always need to plug in that cut point because that's where like the domain is getting chopped off. So you have to decide open or close circle. And then I cut you a break on the other one. What kind of function is this? Constant, it's going to be a horizontal line at 4. You're just going to start it at 3 and closed circle. Looks like a clock hand, sort of. Continuous or discontinuous? Right, so we're going to say discontinuous. You can abbreviate. At x equals, you should say where the location is. Discontinuous at x equals 3. Flip it over. We got 2 more. All good? Oh my gosh, this one got broken into like our flip book. Okay. Where does the first cut happen? Or actually, they all happen at 1. Interesting. All right, x cubed. That's going to be the regular old parent function for x cubed. So where is it centered? Yeah, we didn't move it. So the origin, we just only want to graph it up to 1. This cut is happening at 1. And what kind of circle will we put there? Open circle. So we're going to have an open circle at 1, 1, and it's going to do that. It would be like, are you guys seeing how it would be the wiggly thing? It's just we amputated it. Like you just chopped off that part. It's just the regular old parent function though, which is cool. Now, this is just a point 2 at x equals 1. So that's literally just a point at 2 Like it's the point 1, comma 2. That's it. At x equals 1, you're putting a point at 2. Let me zoom in. It'll look like that. And then the last one, what kind of function is that? All right, square root, it moved right 1, up 3. But at 1, you have to put an open circle. So when you go right 1, up 3, it's open. And then I need a couple more points after that. What do you want to try and plug in? It has to be something bigger than 1 because we want it from 1 onwards. 2. 2 minus 1, 1. Square root of 1, 1. Plus 3 is 4. So 2, 4. Now think about it, because the further out you go, the harder it gets. Think about it for a second. What would be another okay number to plug in? 5? I agree, because 5 minus 1 is 4. Square root of 4, 2, plus 3 is 5. So 5, 5. So something like that. That looks cool. It's a cute little graph. It's neat. It is very, very mixed up. And is it continuous or discontinuous? Yeah, discontinuous at x equals, bless you, 1. What's that? Like, because it's floating? Yeah, I like it. It's like, haha, fooled you, points over here now. Na, 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 na. All right, one more. Negative x, what kind of a graph is that? Linear with a oh yeah, it's going downwards. So a -1 slope, we only want to go up to 0 though. And what kind of circle? Open. So you're going to have an open circle on the origin. And see how this is a -1 slope, like it's going down 1 over 1, decreasing as we go left to right. The whole line would look like this. Like that would be the whole thing. It's just we chopped off this part of it. Like this would be the whole line. And again, some people like to graph the whole thing and then just erase the part they don't want. That's fine too. Open circle. All right, what is this? Just x, right? It's also linear, but a slope of +1. And we're going to start at 0. What kind of circle? Closed. Now there's already an open circle there. If it's going to get closed and they link up, you're just going to fill it in. And then do your +1 slope, up 1 over 1. So that is the point that I'm trying to get across. What is this the graph of? An absolute value is just 2 lines. And I've been saying that since it's linear on both sides. It's just this has a negative slope and that has a positive slope. This is another way of writing the absolute value graph. Cool, it's cool, guys. All right, listen. Your quiz is not next class. It's the class after that. I put this here for 2 reasons. Number 1, so you can already be reading it and looking at it and thinking about what's going to be on your quiz. And also, I just had space on the paper there, and I like saving trees. So since there was room, I just put it. Does that make sense? Don't stop listening to me. I am going to give you the rest of the time. So you're going to have plenty of time to get your homework done. But the homework is a little interesting on Delta Math. Not bad. It's just interesting. And I want you to watch. We'll do 1 or 2 together. Just look so you don't have a question later. What homework are we on? It says it up there. 2. All right. So we're going to go down to homework 2. Evaluating. That's when I was like, hey, what's f of 2? What's f of 7? You just look at the graph and figure it out. I think you'll be okay there. Graphing them. Watch. Just don't look away. Just watch or you're going to have a question later. What type of function is this? Quadratic. So watch what you're going to do. You're going to pick which one of these. The U shape. Okay. Now, how did it shift? Now, do you see the little point in the center of it? That's the only point you can manipulate. You cannot manipulate any of the rest of this. So what I'm going to do is move it up to 4 and it'll kind of like, do you see how it grabbed to that point? Like how it does that? Okay. So now I'm going to hit done. Then it lets you decide the domain. We want it for x smaller than 1. So that's everything to the left side, but I'm going to bring this down to 1. Do you see that? What kind of circle? Now, if I click the point, do you see how I can turn it open? It will like toggle between them. Then I'm going to hit done. Still with me? What kind of function is this second piece? Constant. So I'm going to choose the line. Now, do you see that dot on it? That's the only point you can manipulate. I want to drag it to where? 3. Good. I'm going to hit done. Now I want that from 1 to 7. So I'm going to bring this into 1, bring this into 7, and then what kinds of circles do I want? All right, open on the first one, closed on the second. I'm going to hit finished. Watch. If you scroll down here, do you see that red button that says start over? I'm going to stand up when I say this because this is really important. Because it's at the bottom and it's a huge red button, it's kind of screaming, push me, push me. What happens all the time is people get done with all the work and then click start over. And it is like so horrible. So just make sure you don't hit that red button. Okay, watch what I am going to hit though. I'm going to click finished. And once you are all done, you can click submit answer. Don't hit start over. Okay. And now I actually have no idea if any of that showed up on the video because I didn't share my screen. So you heard me say everything, but not see it. Whoops. Let me just share screen and do one more. It won't hurt you. If you feel like you've got it, go ahead and start your homework. If you want to watch me do one more, I'm just going to do this for the sake of the people that are absent so they can actually see this. I'm sorry, I forgot to hit share. All right, this first one's linear. So I'm going to choose the line. It's a negative slope. If you needed to move it around, you could, but it's going to stay centered. I'm going to hit done. I want it for less than -1. So I'm going to pull this into -1. And I want an open circle. So I'm going to toggle that to be an open circle. This one's square root. It went left 1. I'm going to hit done. And I want it for greater than -1 and also an open circle. Hit finish, not that red button that says start over, and then submit answer. Okay, good. Now the people that need to watch the video have got that as well.